Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced Stream. I'm Richard at Richard on the MakeCode Forum.
I'm Joey at J1 Bill the MakeCode Forum.
And I'm Thomas at Sparks of the MakeCode Forum.
And today we're going to be starting a new game. So I have been playing a lot of a video game recently. Joey, what game have I been playing a lot of?
The original Donkey Kong, actually.
No, it's the new Donkey Kong Bonanza for the Nintendo Switch 2, which I gotta say is very, very good. If you are lucky enough to have a Switch 2, you should play Donkey Kong Bonanza. It's like, I didn't think the Super Mario Odyssey team could make a game better than Super Mario Odyssey, and they somehow have. It's really good. Anyway, it's one of the things that's in it, though. The thing that is kind of like the top level feature is that you can pretty much destroy everything. So you can just burrow through the ground and break stuff, and they do a lot of really cool things with different types of terrain and stuff like that. And so I was like, well, we can't do that in arcade really because it's a 3D game and all of that good stuff. But I want to make a game where we do have some terrain that can get destroyed. And so I was trying to think of some games that have had that in the past in kind of a 2D mode. And I can think of two. Let's see if Thomas and Joey can guess them.
Minecraft?
2D.
Oh, sorry. Terraria?
There you go. All right, you got one. Joey, you got the other one?
Noida?
No, but I guess that is another one. Cave Story? What?
That's the platform game.
Not anywhere.
No. You can't do that in Cave Story. The other one I'm thinking of is, of course, Worms.
Oh, like the PvP. Yeah.
Okay,
Fair.
well, I should have guessed that this is what I was going to get. Yeah, so Worms is this classic game series that has been released on every console ever. The first Worms game I ever played was on a Palm Pilot.
Wow.
And the way it works is you have this terrain. It's all destructible. You have these worms. And it's a strategy game where you kind of move around and then you can toss a thing. And you'll toss like a grenade or something, right? And it will bounce around and then land. And when it blows up, it'll leave like a big circle in the terrain behind where, it hit. I feel like Tanks, like the browser game, was inspired by Worms. I'm pretty sure Worms predates it, but it's the same kind of thing. We have this 2D thing. You're launching these projectiles, and you're blowing up the terrain. And Worms, you have all these different characters that you're moving, so all of the colors are like a team. And like Joey said, the most fun playing Worms is playing against other people, but you can also just play. There was a good single player mode as well. Yeah, so I thought we would do something that has this type of thing, right? Like this, and also what's in Terraria and Noia and all of that, where we have this 2D terrain. It can be like blown up, and we handle collisions with it, right? So we're gonna have to do some physicsy stuff to make this happen for sure. But I think it'll be fun. So let's do it.
There's a game that came out recently about digging in the backyard we could try and think of.
What is it?
Oh, I'm trying to find it. But it was basically like you bought a house, and the line of it is that there's gold buried in a treasure in the backyard, and then you upgrade all your items to dig into the backyard, and then you find the treasure.
I think it might be called Digging a Hole.
I think that's it.
Yeah. That's 3D, not 2D, but yeah.
It is, but like a digging game could be fun. Just like give it some context.
Yeah.
So we need to tile maps are not going to cut it for this, right? We want to have terrain that gets like actually destroyed. So we're going to use an image. We're just going to use the background image for now. So the first thing I want to do is I want to make some physics that are going to let us detect when we are colliding with this image. All right. And to do this, we are going to. I think we're going to stick in blocks today. So we've done a lot of these physics stuff things recently where we've like overridden the physics engine, and if I wanted to make this into an extension or something, that's certainly what I would do. But I think we can do all of this in blocks. We're just going to be basically implementing our own physics. We're not going to be using the physics, that you normally get for sprites and stuff. And we've done this before for Joey's pool sharks, so it's going to be the same kind of thing. So we're going to add an extension to start, and that's going to be the arcade sprite data, because we're going to be storing our own kind of like velocity information on our sprites. And we're going to go ahead and create a sprite. Let's just make it the duck. And we're going to put it so it's not inside this image. So let's set the Y to, let's just set the top to be like 2, just a little off from the top. There we go. And we want to make it so that we can move this guy downwards, but stop moving it when it hits the wall. All right. So we're going to start by just doing basic velocity stuff. So we're going to go into sprites. We're going to grab the sprite data block, set number, and we're going to set VY to 50. Now we are going to go into an on-game update, and we're going to make our physics happen inside of this on-game update. Before we do, though, there's a block I want, so I'm going to go into extensions, and I'm going to go ahead and do ricknull/arcade advanced blocks. Yes. This is an extension that I've shown off before that we keep meaning to do something with. But basically, it just adds a bunch of new blocks to all the categories that have like some nifty features that aren't normally there. So now there's always an advanced section down at the bottom. And the thing I want specifically is I want the milliseconds since last frame. This guy right here. So this is the amount of time that has passed between the current on-game update and the last on-game update. And that's very important for physics. So we're going to go ahead and make a variable. We're going to call this DT. And we're going to set it to be the time since the last frame in seconds. So we're going to divide this by 1,000. All right. Now we're going to loop over all of our sprites of kind player. And let's give this guy a VX also, just so there's something there. And we're going to go ahead and change their X by the VX times this delta time we just made, this DT. Make sure we use value, not my sprite here, since we're in this loop. All right, VX, and we're going to multiply it by DT. All right, and we'll do the same thing for Y. Make this VY, and there we go. Okay, so we should now see this guy. Yeah, there he goes. Cool.
I think we want to... Oh, yeah.
What's up?
Nothing. Just reading the blocks wrong.
All right. So you can see we've implemented our own velocity. It's going to go ahead and fall down here. But we want to make it so we can detect when it hits something and stop, right? So we need to detect when it hits this background image. So right now, let's just do that detection. We won't actually make it stop yet, but we'll change the background color when we detect that it's overlapping, just so that we can make sure that we have like the overlapping right. So we're going to go ahead and put in an if here. And we need to check if we are overlapping with this. And we do need to do pixel perfect overlaps. So we're going to go into sprites. We're going to grab the overlaps block. And I guess we're going to have to create a secret sprite, which is going to be our background. So let's go ahead and maybe we shouldn't use the background image. We should just use a sprite.
Yeah.
And we'll give it a new kind, which is going to be background. And there we go. And so we're just going to do the standard overlap check block right here. Say if value overlaps with, and then make this be our background sprite. Then we're going to set our background color to red. Yeah. Okay, so that's working. Doesn't change until we actually hit the hilltop. All right, cool. Okay, get rid of that. So what we want to do is we want to stop ourselves. We want to stop our movement, right? So we're going to go ahead and basically what we're going to do here is we're going to zero out our y velocity. That's the idea. But I'm wondering now, this is probably not the best way to do it, mostly because, so right now we are going to be moving by possibly more than 1 pixel in this step, right? So this delta time here, it could be any amount of time. There's a variable amount of time in between each frame, right? And if we had a high speed, say we were going at 200 pixels per second, and this takes enough time that when you multiply that 200 pixels per second times the delta time, we end up with a number that's higher than 1, right? So what could happen then is we move ourselves more than 1 pixel into this thing. So let's try to just show this off. We're going to go ahead and put in our set vy to 0 in here, and we're going to change our vy to be 200, and we'll see how deep we get into the hillside. Okay, so we're like 2 pixels in there, when really we want to stop at the top. And so what we could do is we could do what we do in the physics engine, which is like we detect how much we're overlapping with the thing and we're bouncing out. It's much easier in the physics engine because we have everything aligned to tiles. But that's going to be complicated. So what I think we're going to do instead is we're just going to move 1 pixel at a time, and then we will undo the last 1 pixel move. So this is more computationally intensive. But as long as we don't have a ton of sprites, it's not that bad. And this is going to let us, actually clear our velocity at the right point. So let's make 2 variables. We're going to make 2 variables. We're going to call them dx and dy. All right. The Battle Brothers are at it again. You two, stop scrapping. Ugh. All right. If this gets too rowdy, I'm going to have to put auto in timeout. All right, I put auto in timeout. 1 sec.
You've been playing any good? Oh, gee. I auto. I auto.
I haven't been playing any good autos lately, no.
Playing any good games lately?
Nothing in particular, really. Have you?
Nothing specific. I got into Tetris again.
Ooh.
I say again. The first time, really. I've played it many times and never really enjoyed it, and then suddenly I was enjoying it. So that's fun.
Mildly.
Enjoying what?
Tetris. I've played it many times, and usually I don't enjoy it. And then suddenly, I don't know what happened. I was like, oh, this is fun actually now.
That's crazy.
Yeah.
Tetris is super fun. Okay. Oh, man, I hate putting Otto in timeout, but he's overstimulated. He just needs to chill out. Often I will put him in timeout, and then he'll. It's not, it's not like a punishment. It's just like, after a while, he calms down in like 10 minutes, and then I let him out again.
Mhm.
But often when I open the door to let him out of where he's in timeout, he will just stay in there because he's like, nah, I'm okay now.
It's
So
pretty comfy in here, actually. Yeah.
Yeah, I don't think it actually bothers him all that much.
Mhm.
All right. So we're going to go ahead and we have this dx, we have this dy. We're going to change, let's move by 1 pixel at a time. So we're going to do a while loop. We'll say while, let's do an or. Dx does not equal 0, and or dy does not equal 0. All right. So in here, what we're going to do is we want to move our dx or dy closer to 0 for each step. So right now this is just going to loop forever, so we're not going to start here. If our, let's go ahead and, I'm sure there's a nicer way to do this, but we're going to say if our dx is less than 0, then we're going to go ahead and change need to do the no, I do want to change. Yeah, we're going to go ahead and do change value x by the max of dx and -1. Okay, why are we doing this max of business? So we want to change our x by -1, right? But we want to, there's going to be a fractional component of this, right? So if we are, say we have to move -1.5 pixels, we move by -1, and then we don't want to move by -1 a second time because then we've moved -2, not -1.5. So by doing this max, we move by -1, and then we will move by -0.5, basically. And we need to go ahead and adjust our dx now. So we need to change our dx value. So we're going to go ahead and do change value vx, or sorry. We don't want to change our vx. We want to change our dx. We want to do change dx by, and it's going to be max of dx and -1 times -1 because we want to make this positive. All right. So now our dx is going to get closer and closer to 0, right? We're going to go ahead and do this the exact same thing if dx is greater than 0, except obviously we're going to be flipping this sign around. So for this one, we're going to be doing the min of dx and +1. And we're going to be doing the same thing here where we multiply by -1, but we're going to be doing, again, the min of dx 1. There we go. Now we need to do the same thing for the dy. So change this to dy, change this to dy, y, dy, 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 and y. Okay, so we should, there we go. We just move down 1 pixel at a time now, which is good. We haven't actually moved this inside of our while loop just yet, so we need to do that. But we have, at least our code is running like it was before. We're going down at 200 pixels per second. All right. So we now need to detect the overlap. So we're going to go ahead and put our overlap check inside here, see if we're overlapping with the background. And if we are, then we want to basically clear our dx or dy, depending on which one made us actually hit. So we're actually going to do 2 overlap checks, I guess. So if we overlap check after we move our x, then we want to take this thing. We want to set our vx to be 0, and we want to set our dx to be 0. So we want to clear out all of our movement. Like that. And we are going to we want to basically undo our move. So I don't know how we're going to do that just yet, but we'll do it in a second. Okay, same thing here. We're going to be clearing vy and clearing dy. Okay, so we should now be overlapping by only 1 pixel instead of 2. So there we go. All right, we're overlapping 1 pixel because now we're going 1 pixel. We are detecting that we're overlapping, and we're stopping. But the last thing we want to do is we want to move ourselves 1 pixel back out. I guess we need to basically store if it's a -1 pixel or a +1 pixel, which means I think we're going to have to make 2 more variables here. Okay, we're going to call this new variable. This is going to be ddx because it's the amount dx is changing by. All right. And we're going to, let's see. All right, let's see. Is there a way for us to be super clever and simplify our code here by doing this? Wait, I want to see. So if dx is less than 0, we want to set ddx to be 1. And if dx is greater than 0, we want to set ddx to be -1. Else we want to set it to be 0, like that. And then let's do the same thing for the dy. So we're going to make a ddy. Wait. First we'll change these 2 to be dy, and then we're going to make this one be ddy. Great. All right. So is there a way for us to be clever with this dx less than 0, dx greater than 0 business now that we have this in a variable? I actually don't know if there is.
It's like you could store the like max of dx and -1 or min of, like, that could be ddx instead of 1 and -1, but it doesn't simplify things too much. But it would allow you to get rid of the if-else's inside the while.
You know what we could do is, instead of storing a dx and dy like this, we could just have one thing, which is the distance that we want to move. And then we store a dx and dy, which is basically the distance times the cosine and sine that we subtract from the distance each time. So we subtract 1 from the distance each time. But this would also give us more accurate collision detection, because right now we're always doing dx and dy by 1 or -1, which isn't actually accurate to the angle you're moving in. And if we do it that way, then the dx and dy will just contain the sine in addition. So I think that'll be slightly easier. So it's also possible that we should just, instead of doing a vx and vy, do a speed and angle.
Yeah, could do. Yeah.
Yeah, let's try that. Okay, we're gonna refactor this. So let me do a save. Before you blow everything up, always good to do a save. Okay, we're gonna change this to be speed 200. not spelled like that, right? And we're going to make this be our angle. Now we want this to be going downwards. So the downwards angle is going to be 90 degrees. So, all right, get out of here. The downwards angle is 90 degrees, right? So 0 degrees is to the right, and then we go clockwise. So 90 degrees is straight down. 90 degrees in radians is equal to pi over 2. So we're going to have to, I'm just going to type in pi.
I'll be here a while, Joey. Just type it in pi.
No, I'm not.
It'll be fine. We'll be here, next year or two.
Like my favorite thing to mention whenever we're doing this sort of thing, if you feel like you have to get a pi constant from somewhere, you can just type 3.14. It's going to be good enough for you like 99% of the time. I just happen to know 5 digits of pi, so I just went ahead and put in 5 digits.
Mm-hmm.
All right.
I think 3.14159 is about where it sounds right, and then the rest of it is 26.
Yeah.
Like, who cares? 3.1415926.
365358979.
Something like that.
Bunch of nerds.
Like that's like where it goes from like, yeah, that's cool, I remember that. It's like, I kind of regret remembering that.
I think you might be biased by how much you remember.
I am, yeah.
Yeah. Although, yeah, I guess you didn't know the 6 after that.
The 26 after that, right?
26, 159, 26. Yeah, you're right.
Okay. So we are going to set our dx to be the cosine of our angle. And we're going to set our dy to be the sine of our angle.
Mm-hmm.
Like that. And we're going to go ahead and say, we're going to take our while loop that we were doing before, and we had this while dx does not equal 0 or dy does not equal 0 business. We're going to change this to be distance is greater than 0. All right.
Better already.
Yep. And inside here, we're going to do a change distance by -1 because we're going to be moving by We're going to be moving by 1 pixel each time. All right. So in here, we're going to go ahead and change x, and instead of doing this max business, we can just do change x by dx and change y by dy. We are going to have to do something here because this could move us a fraction of a pixel farther than we need to.
Yeah.
Right. But we could also just, not care about that particularly. And we're going to go ahead and grab our overlaps with background. So if we overlap with the background right here, then we're going to go ahead and change our x by -dx. Same thing right here, y by -dy. We'll go ahead and make a variable that's did collide. Or I guess we can go ahead and say, actually, let's just set dx to be 0. Set dy to 0. And yeah, okay. So that should actually do it. So there we go. We now stop on top of our hill. All right, so as I mentioned, there's kind of an error here, which is that we could end up moving a fraction of a pixel farther than we need to each frame. All right. And the reason why is because we have a, we're changing by this dx dy, and we're going to be moving our distance by -1. But, okay. So I see what we have to do here. So our distance is always a positive number, right? We're going to be subtracting 1 from this each time, right? So imagine we have 2.5. We're going to subtract by 1, 1.5. We're going to subtract by 1.5. And then for that last frame, we want to move by 5 pixels instead of 1 pixel, right? So to fix that, we actually just need one check up here at the top, which we're going to say if distance is less than 1, then we can just set dx to be dx times whatever the distance is.
Yeah.
And set dy to be dy times whatever the distance is. All right, this was, look how much code we had before. This is way less.
Let's do it simplify a little bit,
Yeah.
A little bit nicer.
All right.
Is there any, what is the setting dx to 0 and dy to 0 doing for us in that?
So if we collide with the thing and we're going at an angle,
Right,
we want to clear out our whatever thing did the collision, but we want to keep moving in the other axis.
Gotcha.
Yeah. And then we want to go ahead and clear out our velocity as well, I guess. So I don't know. Actually, we can talk about what we want to do when we actually have a collision. Right. For now, I think this is fine. Just stop it.
Mm-hmm.
But if I set the angle here to be like, let's do, I don't know, 1.5 divided by 2, that's going to be like going to the 45-degree angle here. Then, okay, well, that was actually kind of an uninteresting thing because we just immediately run into a corner. I was kind of hoping we would hit up here. Let me set the x to be something else. We'll make this be, I don't know, 40. I want to hit the top of this guy. Nope. Come on now.
No.
50. All right, almost there. We're still getting caught on this little divot right here. So we're going to make this be like 52. There we go. So you can see we did a little slide. Right, let me slow that down.
I'm actually surprised that we continued falling after we hit it.
What do you mean continued falling after we hit it?
Oh, I guess we don't clear the velocity.
Yeah, exactly. We don't clear velocity right now.
Yeah.
Because we kind of have to decide what we want to do with that, honestly. Okay, so we've got our basic physics and collision with the background, right? That's good. We now can't really go much farther until we decide what we want this game to be, right? So let's talk about different ideas. So I don't know. We can, Joey, do you want to talk a little bit about what Noia does? How do you spell Noia, by the way?
Noita, Noita. What does it do? I guess you blow stuff up with wands that you make, and that's the main thing about it.
So it's a platformer, right?
Yeah, you get a platformer. There's a you get a air pack, something like that, magic floating device, like not a device, but you have magic floating powers because you're a mage. You make wands that can do stuff, so you can get like explosions or little shots, right? That's kind of interesting. So you could have different tools basically to dig. Yeah. Then besides that, it's kind of like Worms feeling.
Yeah. So Worms is also technically a platformer. So in Worms, you don't typically move your worms very much. They can't jump. You can move them left and right to reposition them, and as part of that, you can also fall. Once you start falling, though, I believe that's like the end of your turn. There's also like a jetpack and stuff that you can get that makes you like fly upwards, so you can kind of reposition. And a rope, famously, the rope is fun.
Parachute.
So reposition your worms.
I don't remember the parachute that well, but I remember it being in there.
Yeah, I don't remember what that does either. So yeah, and then for tanks, right, it was basically Can you move your tank? I honestly don't remember. I feel like you can move left and right a little bit.
Can, yeah.
Yeah, I think you
Like
have like
move,
an amount
turn,
of fuel each turn or something
yeah.
where you
Maybe
can reposition
angle,
it.
velocity.
Sounds right.
Yeah.
All right. So I want to have terrain getting destroyed, right? And I don't much care how it happens at this point.
Mhm.
So we could do this kind of like arcing projectile type thing, right? Where when it hits, we blow up and we just take out a chunk of this terrain. Or we could do something more like Noya and more like Donkey Kong Bonanza, where it's a platformer and you can like punch or shoot a projectile or something, and that would destroy the terrain in front of you.
Yeah.
Right.
The first option does feel a little bit more like Angry Birds, I guess, with the feeling behind. Like just you would be launching something and blowing things up.
I mean, yeah, but it's pretty different, right? Because in Angry Birds, it's like stacked blocks.
Yeah.
And it doesn't like affect the terrain that you move over later.
I was just meaning in terms of like the player's interaction, maybe like the launching it instead of.
Sure. I was thinking more like tanks or worms, though, where you have an angle that you're kind of like doing, and then you have a power level, and that kind of determines how far it goes.
Makes sense.
All right. Let's see. So, let's think about the platformer thing for a second, because I think that's going to be probably too hard to do in a timely manner. But it would be maybe the most interesting thing for us to do. So let's talk about how we would implement that. So because we're representing our speed as an angle and a direction, we would probably want to. Okay, so we're going to have gravity, of course. We're going to have the left and right buttons basically apply a speed to your character, and then the gravity is going to be what makes you fall down. And then we'll have a jump, which should work just fine. All of these things should work together just fine. It's not going to play very well though, because we have pixel perfect overlaps, and as soon as you hit, you won't be able to like walk up this slope.
Mm-hmm.
You'll just get stuck a bunch.
Yeah.
Unless we made all of our levels no slopey, just boxes.
But the slopiness comes from the will come from the explosion. Right?
If your explosions are round, it will. But your explosions could be boxy too. Then we may as well just use tile maps, but you get a little bit more.
Like, are you talking if we throw some perfectly rectangular grenades?
Yep. Exactly.
Yeah. Shaped charges.
A bold choice,
You got a square fist back. And it just knocks out a square in the wall.
Yeah. So I think that if we were to try to overcome that, what would we do? So we would want to be able to walk up slopes of 1 pixel or maybe 2 pixels, right?
Mm-hmm.
Yeah.
So I guess the way we would implement that would be we would move dx, we detect an overlap, and then we would try to move dy up 1 or down 1. And if either of those prevented the overlap, then we would just accept that and keep moving.
Yeah. Mm-hmm. Maybe only if you have a key down or something, but yeah.
Yeah. So let's give that a shot. Okay, let's implement our basic platformer stuff here, and give this a try. So we're going to basically right now we have the speed angle, and we're going to keep that, but we want to we're going to need a dx dy, a vx vy in order to do the movement. It's just going to be way easier to think about that way, right? So we'll calculate our speed and angle as the first step in this. So let's actually take this, put it up here, and we're going to go ahead and change this back to a vx vy. So we're going to set our vy to be 50. We're going to set our vx to be 0. And our speed is going to be equal to the distance formula, basically. So we're going to do, inside of math, grab a square root, grab a power, and in addition, some squares here. There we go. Put this in here. And then we want to put in our Vx and Vy. So we're going to make this be Vx squared, and this is going to be Vy squared. Okay, so that's our distance. Like that. Now for our angle, we're going to want to set that to be equal to our magic block that none of us really understand how it works, but we know how to use it. A tan 2. So if you remember A tan 2, the way this works is, unlike everything else in the world, you put Vy as the first argument, you put Vx as the second argument, and out comes the angle in radians. It's magic. Hooray. And change these both to be value. And I think we should be back to where we were. So, yep, we're going straight down now. That's good. All right, we're also going to add acceleration. So we're actually going to set our Vy to be 0 here. And we're going to go ahead and put in an AY. And we will set this to be 500, the value we normally use. And now in here, we are going to change our Vy by that. So let's go into sprites. We're going to go ahead and do change Vy by and this is going to be dt times our AY. So now we should fall down. Whoop, there we go.
We probably want to clear Vy when we hit something now.
You're one step ahead of me, Thomas. So now, when we do this right now, even though we have stopped, we are actually constantly accelerating, right? Because we never clear our Vy. So if we were to like move off of this pixel, we would fall down at like 1,000,000 pixels per hour. So we don't want that. We're going to go into here and clear out our Vy when we do a collision on the Vy axis. So go ahead and grab a set data to number. Wow, the context menu on this block is wild. All right, we're going to set Vy to be 0. Same thing up here, set Vx to be 0, even though we're not actually going to use a x acceleration like at all. All right, cool. Now we need to do controls. So we're going to go ahead and grab an is button pressed. Go ahead and put some logic in here. We're going to say if is left button pressed. Actually, what we're going to do is we are going to set our Vx to 0. And if our left button is pressed, we are going to set our Vx, we're going to change our Vx by whatever our move speed is. And this is the point now where we need to make a variable for this. Make a variable, call it move speed. Whoops. So if left is pressed, we're going to change by negative move speed. And if right is pressed, then we're going to change by positive move speed. The reason we're doing it this way is because if you press the left button and the right button, this will make it so they cancel each other out. Why are you angry? Is it somehow thinks that move speed is not a number? You happy now? All right.
Looks like weird.
Okay, so we can now move left and right until we get ourselves into a little thing because we can't jump. All right. Make it so we can jump. We'll do it on up pressed. And in here, we're going to go ahead and just set our VY to 0 minus, wait, what is it? Square root of 2 times the jump height times, oh my gosh, why have I forgotten this? 2 times jump height times gravity.
That sounds right, yes. I put it in a block in Arcade Sprite util because I'm
it won't work for us because we're using our own VY.
Yeah, that's true.
And our gravity is 5. Okay. So now we can jump up and we can like move around and fall down and stuff.
Mm-hmm.
There you go. We made a platformer. Great for us. Okay, so we want to make it so that we can climb up 1 pixel slopes. So I'm going to go ahead and we're going to optimize this physics that we're doing for gravity down because, we don't actually care about going down X slopes in the X direction. Like we don't actually care about slopes in the Y direction, right? If you're falling downwards, we want you to catch on a ledge. We don't want you to get nudged over. Yeah. But if you're moving sideways, we want you to go up or down. Right, so we're going to go ahead and when we do this change VX, we're going to do this if overlaps check. And then we are going to change our Y by -1, and we're going to do another check. If we overlap with the background after changing our Y by -1, we're going to go ahead and change our Y back. And we're going to continue with our, zeroing out our DX. Else, nothing. We're good. We did it.
Yep.
All right. So, look at that. Look at that. Just climbed over slopes all day. Whoops, fell off the edge of the world. Back. All right. That'll happen. All right, cool. All right. Now, we're actually kind of lucky that in this background image I drew, we never had a thing of more than 2 pixels. But now if I go ahead and do this is an insurmountable obstacle. Right, so, nope. We're cool with it, apparently.
Oh.
Oh, I see. It's because our sprite is...
It has a little edge, so it's not...
Yeah.
Gotcha.
Yeah, so I actually have to do 1 more. Nope. Wait.
Why is this
okay, wait, no. We have to do 1 more. Right, all right. Yeah, I just counted wrong.
Oh, it's an extra jagged. Okay.
There we go. Okay, so now this is a thing we cannot get over. There we go. Bam. Okay, that actually feels pretty reasonable, I have to say. Kind of having these beveled edges like this is like helpful, right?
Yeah. Mm-hmm.
We can go over in the other direction because this one actually has a bump, but you can't go over this direction. But you can go over this direction just because of how this duck happens to be shaped.
Interesting.
Cool. All right. Well, this was easy. All right. All right. Yeah. Well, I think we're kind of out of time for today, but we got way more done than I thought we would. So join us on Wednesday when we are going to be taking this and doing the actual destruction part. So, we'll kind of decide exactly what we want to do here, but it will be fun to kind of have destructible terrain. The other thing that the other part we kind of have to figure out about this is we need to decide how big we want to make the world, because we could just say, this is not a game for hardware and just, never run it on hardware, which, I think right now it'll actually run just fine on hardware. But the bigger the world gets, every time we change the underlying image, that's going to cause the memory to spike, because that image will turn from a static background image into something that's held in memory. And each screen has 10 kilobytes. So if we have like a Meowbit, which has 96 kilobytes of memory, and 20 of that is already taken up by the 2 screens that we always hold in memory, then we have at most, 3 or 4 screens before we're going to run out of space, because there is also a certain amount of memory that takes just to run the program,
Yeah.
And so, I guess you could have a reasonably small level that was just 3 or 4 screens wide, but you would really be pushing it. I feel like you'd really be pushing for an out of memory exception there. But, maybe that would be fun to kind of work around, we could talk about it.
Okay.
You could like clear out ones that when you walk away from them and have sort of tiled levels, but then you'd forget the destruction that occurred if you went back. So
yeah. Unfortunately, there's no real way around that because we don't have a disk we can write to.
Yeah.
I don't actually know how much disk space the hardware has.
I have no idea.
I know it's on the order of kilobytes, but I don't know how many. So the settings extension actually has a limit on it. If you write too much data, you will eventually hit the limit, which is what we would be doing here. We would just be writing settings with the extension, just writing some buffers. But, this might be fun to do just to make this work specifically on hardware. Could also be fun to make this work on multiplayer. I don't know.
Mm-hmm.
We'll think about it. Anyway, join us on Wednesday where we're going to be playing around with this. Also, note on Friday is going to be our mini game jam stream. I think July is the worst month for mini game jams because this happened last July too. We got basically no submissions in July because I just assume everyone's on vacation. Yeah. And so far, I think there have been 2 submissions on the forum. So please, if you want to make a game, go ahead and just slip it in there. We'll play it and we're going to give it a lot of time because we only have 2 submissions, like I said. But we'll figure out something fun to do on Friday, with the remaining time that we have.
What's the theme for this mini game jam?
It is game show.
Oh, yes.
Yeah, if you want to make a game show game. But and then the next big game jam is going to be in October. So, yeah. Yeah, Pimink, I agree. It's kind of a hard theme, but also people requested that I do it. I got people pinging me on the forum being like, hey, didn't you say you were going to do game show? Let's do game show. And I was like, all right, we'll do game show. And then, yeah, I guess, it just didn't line up with their schedule, which fair enough.
Just how it goes sometimes.
Anyway, I'm Richard Outridge on the MakeCode forum.
I'm Joe at J1 on the MakeCode forum.
I'm Thomas at Sparks on the MakeCode forum.
And we'll see you on Wednesday. Bye, everybody.